Hi, this is a video on the remainder and factor theorems. I'm going to start out by talking about the remainder theorem and doing a couple of examples with that. And then I'm going to talk about the factor theorem and do a couple of examples using the factor theorem so you can see how the two are related. So to start off, the factor theorem says that if a polynomial p of x is divided by the quantity x minus a, then its remainder will be p of a. So let's take a look at this. So we'll have a polynomial p of x divided by some quantity x minus a. So we can rewrite p of x to be, so p of x equals q of x, where q of x is the quotient, times the divisor x minus a, the quantity x minus a, plus r, where r is our remainder. So now let's take a look at p of a. So we will substitute a for wherever we see x. So p of a equals q of a times a minus a, or the quantity a minus a, plus r. So now we can simplify. So we get p of a equals q of a times 0 plus r. So now q of a times 0 is 0, so we get just r. So this is basically saying that p of a equals r, which is our remainder, and that's what the remainder theorem tells us. So now we're going to try a couple of examples. Alright, so example 1. X cubed minus 5x plus 1 divided by x minus 3. So we could do this regular long division way. Okay, so I'm going to set it up to do long division. So I put in a placeholder because we don't have an x squared term, so I put plus 0x squared. So now we just do regular long division. So x cubed divided by x gives us x squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. So then we draw our line, change both signs. These cancel, and we get 3x squared, and then we bring down negative 5x. And so now 3x squared divided by x, we get positive 3x. So then 3x times x gives us 3x squared. 3x times negative 3 gives us negative 9x. Then we draw our line, change both signs. So these cancel. And positive 9x minus 5x gives us positive 4x. And then we bring down our 1. So then 4x divided by 3, or that, I'm sorry, 4x divided by x gives us 4. So then 4 times x is 4x. 4 times negative 3 is negative 12. So now we draw our line, change both signs. So then these cancel, and we are left with 13. So our remainder is 13 over the quantity x minus 3. So now, instead of doing that long division, the remainder theorem says that we can evaluate our function at a. So in this case, our a value is 3. So if we evaluate our function at 3, so if we substitute 3 in for x, we would get 3 cubed minus 5 times 3 plus 1. So then 3 cubed is 27 minus 15 plus 1. So then 27 minus 15 is 12 plus 1 is 13. So you will see that the remainders match up. So the remainder theorem does in fact work. So if you evaluate your function at a, then you will get your remainder to be the same thing as if you did regular polynomial division. So now let's try another example. So let's look at example 2. So x to the 4th minus 6x cubed plus 3x squared plus 8 divided by x plus 1. So we can do polynomial long division. So x plus 1 on the outside, and then x to the 4th minus 6x cubed plus 3x squared plus 0x plus 8. Remember, when you do long division, you need to put a placeholder for any terms that are missing, because you want your terms to go in descending order. So 4, 3, 2, 1, and then x to the 0 is 1. Alright, so then x to the 4th divided by x is x cubed. X cubed times x is x to the 4th. X cubed times 1 is positive x cubed. Draw your line, change your signs. So these cancel. And we get negative 7x cubed. So then, and then we bring down our 3x squared. So then negative 7x cubed divided by x gives us negative 7x squared. So now we multiply, so negative 7x squared times x is negative 7x cubed. Negative 7x squared times 1 is negative 7x squared. Draw a line, change both signs. These cancel. We get 10x squared. Bring down our 0x. 10x squared divided by x is 10x. 10x times x is 10x squared. 10x times 1 is 10x. Drawing a line, change both signs. So then these cancel, and we're left with negative 10x. Bring down our 8. Negative 10x divided by x is negative 10. Negative 10 times x is negative 10x. Negative 10 times 1 is negative 10. So then we draw our line, change both signs. These cancel, and we are left with 18. So our remainder is 18. So plus 18 over quantity x plus 1. So now, according to the remainder theorem, all we have to do is evaluate at a. And in this case, our a value is negative 1. So we substitute negative 1 into our function. So we get negative 1 to the 4th minus 6 times negative 1 to the 3rd plus 3 times negative 1 squared plus 8. So now, instead of doing it by hand and making some errors, possibly, I'm going to show you how to store a value in your calculator. That way, all you have to do is type in the function on your home screen, and it'll tell you. So the way you store a value for x is you hit whatever the value is. So we want our value to be negative 1. So we type in negative 1, store as x. And then we hit enter. So now our calculator has stored the value -1 for x. So now all we have to type in is x to the 4th minus 6x cubed plus 3x squared plus 8. And then hit enter. And we get 18. So our remainders match up again, just like the remainder theorem said they would. So we know that we divided properly, and so now we are done. So now I have a little reminder for you. So when you are looking at your divisor of x minus a, remember this is telling us to evaluate at x equals a, not negative a. So this, not that. So now we are going to move on to the factor theorem. So the factor theorem says that x minus a must be a factor of the polynomial p of x if and only if a is a 0 of p of x. And remember, for something to be a 0, so for a to be a 0, p of a has to equal 0. So your remainder has to be 0 in order for a to be a 0. Does that make sense? Alright, so basically, if if x minus a is a factor, then that means that x, if you set this equal to 0, then you get that x equals a. So, according to the factor theorem, if you know that x minus a is a factor, then you will know that p of a equals 0. And then vice versa, if you know that p of a is 0, then you know that x minus a is a factor. So let's try an example. So let's look at example 1. So is x minus 3 a factor of x cubed plus 5x squared minus 17x minus 21? So the first thing we want to do to apply the factor theorem is to apply the remainder theorem. So we are going to evaluate this function at positive 3. So let's go ahead and store 3 in our calculator. So remember, hit 3, store as x, and then hit enter. So now you can type in this function on your home screen and get what the value will be. So let's type in x cubed plus 5x squared minus 17x minus 21. And we get 0. So if we evaluate p of 3, we get 0. So let's say this is p of x. Alright, so based on the factor theorem, since we know that the remainder is 0, then we know that x equals 3 is an x-intercept and a 0 of this function. So since we know that this is a 0, we will know that x minus 3 is a factor. So x minus 3 is a factor because p of 3 equals 0. So let's take a look at another one. So let's look at the second one. So is x plus 1 a factor of x cubed minus 2x squared minus 21x minus 18? So first, we want to apply the remainder theorem. So we want to evaluate this function at -1. Because remember, we do the opposite. So if we had set this equal to 0, x would be -1, which is why we substitute -1 instead of +1. Alright, so let's store -1 as x. So remember, hit -1, store as x, and then hit enter. And now we can type in our function on our home screen. So we get x cubed minus 2x squared minus 21x minus 18. And then, let's see what we get. And we get 0. So according to the factor theorem, let's see. So p of -1 equals 0. So according to the factor theorem, x equals -1 is an x-intercept, which means that x plus 1 is a factor of x cubed minus 2x squared minus 21x minus 18, because p of -1 equals 0. So you can see that the remainder theorem and the factor theorem are closely related because we use the remainder theorem to apply the factor theorem. So let's try one last example with the factor theorem. So, example 3. So is x minus 4 a factor of x to the 5th plus 5x to the 4th minus 6x squared plus x minus 9. So let's see if x minus 4 is a factor of this function. Alright, so first we evaluate what p of 4 is. So let's get our calculator. Let's store 4 as our x value. So hit 4, store as x, and then hit enter. Alright, so now we've stored x, or we've stored 4 as x. So now let's type in the function. So x to the 5th plus 5x to the 4th minus 6x squared plus x minus 9. So we get a remainder of 2,203. So 2203. Which means that 4 is definitely not a factor of x to the 5th plus 5x to the 4th minus 6x squared plus x minus 9. So we would write x minus 4 is not a factor of if x equals x to the 5th plus 5x to the 4th minus 6x squared plus x minus 9, cos of 4 equals 2,103. So, I hope this helps, and good luck.